think right ngaqalisa ne. Singabangena nje.
Yeah.
So it's easily.
They pick up the sound was, yeah.
Yeah, pick up. Twitch, because okay, because you. Right.
Pick up an message.
Yeah. Good afternoon, everyone. Welcome back for today's session. So today we're gonna continue where we left off yesterday. Just to go through what we went through yesterday. So yesterday we began our session with a unit circle. We described the equation of the circle, that it is in the form of a Pythagoras theorem. So this is our equation of the circle on the Cartesian plane. Yeah. So we went on to prove some of the trigonometric identities. One of them being the quotient rule, that tan theta is equals to sine theta over cos theta. We proved that, and also we proved that the sum of sine squared theta and cos squared theta is equals to 1. And we went on to sine to a compound angles, sine and cos. So these are our equation. And then we proved, we showed trig reductions on how to do some of the trig reduction. We covered the first quadrant, second, third, and fourth. Yeah. So today I'm going to start by defining some of a trigonometric definitions. The first one being the amplitude. So amplitude. So let me write the word definitions. So given an equation there, let's just write any equation. F of x is equals to, okay, let me rather do it as like this. Theta and x. So this is x sine theta. So from this equation, f of theta and x, so function f takes in two variables, theta and x. So from this equation, we have what is called the amplitude. Amplitude. So what is the amplitude? So the amplitude is this coefficient of x in front of your trig function. This x is called the amplitude. Ne? So let's rather search for the actual definition of what amplitude is in full definition. Yeah, amplitude, trigonometry. Yeah, definition. So let's do AI mode. Amplitude is a half distance between the maximum and minimum values of a periodic function. Ne? So Tiwa is the half distance between the maximum and the minimum values of a periodic function. So what does this actually mean? Ne? Okay. Let me just do this. Ne? Given a following graph, ne? So to our amplitude is the half distance between the maximum and the minimum of your periodic function. So umzekelo, for example, so this is our maximum. Excuse us about that. Okay. So we are still defining the amplitude. Okay, let's go back to our AI. So amplitude is half the distance between the maximum and minimum values of a periodic function. Okay. So what does that mean? So given this periodic function, so let's say this here is 1, ne? So our maximum value of this graph is 1, so and our minimum is here is -1. So the maximum, it has a name actually. It's called a crest. Ne? So a crest is the maximum point on a periodic function. Ne? And then here, the minimum point also has its name called a trough. Yeah, I think you spell it like this. So what is the amplitude of this periodic function? So whatever is the half distance between crest and the trough, between the maximum and the minimum. So you have distance of 1 and -1. So the difference between the two is 1 minus -1 is 2. Right. Now, kutiwa it's the half the distance between the crest and trough. So multiply this by half. and you get a what? You get 1. So this is the amplitude of this function, right? Yeah. But also be careful, yeah. Be very careful. Okay. For an example, what I mean, you'll be given graphs like this, right? Where you'll have something like this. Yeah, and so on and so forth. And here, let's say this is 3, and here this point is -1. Yeah. One might say that the amplitude is of this function is 3 or -1. So this is entirely wrong. This is not right. This is not the amplitude of this periodic function, but rather, how do we calculate the amplitude? You take in the distance between, you first calculate the distance between the highest point and the minimum point. So the highest point here is 3, né? And the minimum point is -1. So you're taking the difference between the two. So it's 4. Then the amplitude is half the distance of the difference. Yeah, so it's half of 4 in this case, which is 2. So the amplitude of this trig function is 2. Amp is 2. Right? So this is not this is wrong. So the amplitude is not 3 or -1. But rather the crest of this periodic function is 3, and the trough is -1. So trough is the minimum point and crest is the highest or maximum point, right? Also, you might be given to a dissipating periodic function. So what is a dissipating periodic function? So a dissipating periodic function is function that looks like this, né? But now, yes. So this periodic function is said to be dissipating. Because now its initial amplitude on the first period is rather high than the next following period, né? So for example, if this is 3, then on the following period this is 2, and then the following it's so on. So it's dissipating. So its amplitude is sort of decreasing, né? But not really. It's not decreasing. Amplitude is not decreasing. So what is the amplitude of this function? We're gonna use our definition. That is half the distance between the highest and the minimum point, right? So in this case, the highest is 3, right? For this graph, né? And the lowest is what? Okay, let's just call this, let's say it's 3 as well, but it's -3 since it's below the x-axis. So it's -3. So the trough is -3. Trough -3, crest is 3, né? And we know equation of the amplitude, or rather how we can calculate the amplitude. is the highest point, which is at 3, minus the lowest point, which is at minus 3, times by half, since it's the half distance between the highest and the minimum point. So the answer here is 3. 3 plus 3 is 6 times 1 over 2, it gives you 3. Right, so, excuse me. So we have defined the amplitude, right? So I hope to everyone who's watching, the definition of amplitude, what amplitude is it makes sense now. So we're gonna move to the second definition, or rather second term. So the second term here is what I call a phase. Yeah. So what is a phase? Yeah? So let's write our function once again, the one we wrote. Right, so we said this, so what about this theta? So this theta is actually called a phase of this equation. So let's go back to our AI and ask for it to define our phase definition. Refers to the horizontal displacement of a period. Right, okay. So a phase refers to the horizontal displacement of a periodic function. Right, okay. So what does that mean, right? So given another graph, let's write this. So here, so this is a sine graph. So this is theta values as in axis, but now this is theta axis. So here our theta is actually our phase, so it determines like where in our graph we have shifted, or how many units did we shift, or rather, for in this case of an angle, how many degrees we have shifted, right? So for an example, let's say we shift this graph by 90 degrees to the left or to the right, doesn't matter. So it's sine theta plus 90 degrees. So 90 degrees is here, no? So this is a 90. So if you shift this graph to by 90, it will resemble something like this. So you see now it sort of resembles cos theta. But what we have done, we have just shifted our phase by 90 degrees. So that is it for the phase. And we move to, I think, to the most important definition, of a trig concept which is called a period. So what is a period, Jan? Right. Let me draw a graph once again. Let me just draw a dotted line on this point. Right. So this is 360, 70, 180, and 90. So you can see that our graph is sort of a full graph. This is a sine graph, by the way. For the first 360 degrees, our graph is a sort of, what I'm trying to say, okay, what am I trying to say? So yeah, so for the first 360 degrees, our graph has completed its cycle, it has completed its cycle, right? So for the next following 360 degrees, so should be 720. It starts its second period, right? Now for sine graph, its period is equals to 2 pi. It's not 2 pi, sorry guys. Okay, it's 2 pi, but it's 360 degrees. Excuse me guys, we use irradians when we are at varsity, so that is why I said 2 pi's. But here in high school we are still using periods as a unit of measurements for degrees, for angles. So a period of sine graph is 2 pi. So what about of cos? I'm going to draw a dotted line here as well. 360 degrees. Right, let's look at the graphical cos. Graphical cos now, it reaches this point again after 360 degrees. It reached this point, the very same point, the very same height rather, after 360 degrees. Same applies nalapas. So it will reach this minimum again after 360 degrees. So if this is 180, so this means this is plus 364, 360 plus 80 equals to 540. So this is at 540 degrees, right? So it reaches the same height after 360 degrees as in the same of sine graph. Nalapa, this point here or rather this height is reached once again after 360 degrees. Right, moving on. So what about of, so that means cosine, its period is 360 degrees as well. So, but what about the tangent, the tan? So it's sort of hard to write. Yeah, so this is a graphical depiction of a tan. No, it's not accurate, guys. Yeah, well, so yeah, so this is 0 degrees. So we have these points. Yeah, I think you get the point. But for an accurate depiction of a graph of tan, I suggest you search it and you'll see. But it's something like this. So what about a tangent? What about the period of a tangent? So you can see that it's repeating the same pattern of as the graph, something like this. Now look careful. This graph is between the two asymptotes. Okay, for this particular one, it's between 90 degrees and 270 degrees, right? Then it repeats, right? So this, okay, I'm not sure what value it's at here. But this pattern repeats every after 180 degrees, right? So what I mean by this, let me just redraw this so that it can properly make sense. I'm gonna first draw my asymptotes. So this is 90, this is 270. Huh? Yeah, it's something like this. But all this, it lies between 270 and 90 degrees, or 270 and 270 plus 18. So this means that a period for tangent is 180 degrees because this pattern repeats every after 180 degrees. So for tangent, its period is 180 degrees. So let's go through once more. Right, first of sine. So sine, and then we draw cosine. And then we draw a tangent graph. and so on and so forth. So we said that this height, ne, so this height is reached once again after 360 degrees. So if this is 90, this height will be reached once again. Will be reached once again at 420 degrees. Right. Same applies nalap. This height, this point will also be reached after 360 degrees. But however, for a tangent, this height, this height, let's call it x, will then be reached after 180 degrees. 180 degrees. Here is 360 degrees. Same here is 360 degrees. So that is it for our periods for tangent, cosine, and sine graph. I hope that makes sense to everyone. But moving along, so I think I've covered the definitions of trigonometry, but that's not all of them, but I think those are the most important definitions: amplitude, phase, and period. So let's move along. I want to go to question papers. I know we all like to tackle the questions. We learn by doing, not by listening. So let's do a question paper. So this is grade 11 mathematics, November 2017, paper 2. So on this question, we're going to do let's first do question 4 or 5. What do you think, guys, we should do? Should we first start with question 4 or question 5? Okay, let's start with question 4. Let's just do it in order. So here is question 4. So question 4 says, C, a point on the x-axis, A, -5, -3, and B, 4 and 12 are the vertices of a triangle. AB intersects the x-axis at E. ABC is equals to theta, BEC is equals to A or alpha. I'm not sure. Okay, it's alpha, yeah. BC is alpha, right? So let's calculate the gradient of AB. So how can we calculate a gradient of AB? So we know the formula of a gradient, right? So a gradient is also called the slope. So a gradient, it's usually represented by letter M. Yeah. So on an equation of a straight line, it's like this: mx plus c, where m is the gradient. Right. So what is a gradient? So a gradient is the rate of change in height, over the rate of change in horizontal distance. So what I mean by this is that it's the change in height. So height here too is, so a height is either up or down. So it's the change of a height, which is the change of a y, divided by the change in a horizontal displacement or distance. So this is horizontal, right? It's change of y over change in x, so is our gradient. So in order for us to calculate this gradient, we need, in order for us to calculate the gradient of a line, we need 2 points on that line, right? For an example, we can calculate a gradient of AB because we are given point B and point A, so we have enough information to do so. So let's proceed and calculate the gradient of AB. Wait. So A is what? -5. Negative what? -12. -3, okay, for 12. Okay, deep, okay, I don't know what happened. Okay, something wrong happened. So gradient, change in height over change in x. So we have point A as in -5, -3, and we have a point B 4, 12. So let's proceed and calculate our gradient of AB. So gradient of AB, we're gonna, so this is, call this y1, x1, x2, y2. So change in y is equals to y2 minus y1 over change in x, which is x2 minus x1. Be careful also when you're calculating gradient. If you starting by y2, on the denominator as well, you have to start with x2. And also, if you start by y1 on the numerator and denominator, you have to do that as well. So let's substitute. So y2, it's 12 minus 3. X2 is 4 minus 5. So we get 15 over 9. So this is 5 over 3. So we have calculated the gradient of AB using the 2 points that we were given. But is this the only way we can use to calculate the gradient of a line? It turns out, no, this is not the only way you can calculate a gradient. So what other way can you use to calculate a gradient? Okay, I'll just show you. Right, okay, I'm going to draw a Cartesian plane. Draw a Cartesian plane. Right, so we have the y and the x, right? So I'm also going to, basically I'm going to draw a unit circle. also I'm going to draw just a simple vector. Ne? Right. I'm gonna draw just an angle. Let's call this angle or theta. Ne? This is angle of inclination. So how then do we calculate the gradient of this vector here, or of this line? Just let's call it a line. How do we do that? Let's call it to R. Ne? So we know that to sine theta, ne? Sine theta is equals to opposite over hypotenuse. So hypotenuse is our vector and opposite is our y function, our y value. Cos theta as well is adjacent, which is x over tan theta is y over x. Let's look at this part here, got tan theta. So tan theta is equals to y over x, right? What about our gradient? It's an equation of the gradient. Equation of the gradient, et change in y equals to change in x. Now, if we were to remove these triangles here, this triangle means change, by the way, it's a symbol for change. If we were to remove them, you would see that these two are the same. Tan theta is y over x, the gradient m is also y over x. So this then can be used to conclude that actually another way to calculate the gradient is that the gradient is equals to y over x, which is equals to tan theta. Theta being the angle of inclination with respect to the x-axis, not this angle, not this, but this one with respect to the x-axis. So we can calculate the gradient using this formula other than using this one. Right, let's move on to the next question on our question paper. So determine the coordinates of point E. So we already have okay, let's look at line AB. So how do you write Kanenya? Taluva skupala njani lapha? Hayi ngifuna ukubhala lapha ephepheni. Oh, okay. Can I write now? Okay. Okay. So now we have calculated a gradient of AB, and we find out it's 5/3. But now let's determine the coordinates of point E. So how do we do that? We know equation of a straight line, that it's mx plus c. So this is our y value, this is our x value, this is our gradient. So what does C represent? So C represents a and y-intercept, right? But now, let's calculate to E. So E is not the y-intercept, it's rather an x-intercept. But now we know that at an x-axis, the value of y is what? Is 0. Right. So we can calculate that. We're gonna substitute, né? So so now I'm trying to calculate the coordinates of E. So we know that the point of OE is this, right? Y is 0. We do not know what the value of x is. So let's substitute our values. So 0 is equals to our gradient, which is 5 over 3 multiplied by x plus c, right? And we know that so then that means that 5 over 3x is equals to negative c. Right? Oh, wait. Okay, now we do not have enough information to actually calculate the x coordinate. Okay, we have calculated the gradient, right? We know that the value of y at this coordinate 0. And then how do we find of x? Excuse me, guys. Let's think. Okay, we don't have enough information to use this approach that I have used. Okay, we're gonna come back to this question because it's dribbling me now for some reason. Let's move on to the next question. Determine the size of alpha round off to the nearest whole number. Okay, so since we know that now we have a new way to calculate a gradient, which in this case will tan of alpha, and we know that our gradient is 5 over 3, and we can then calculate alpha, which is alpha is tan 5 over 3. It will give you a certain value of which I am not sure of, but this is the way to calculate to alpha, right? Using the other equation, this equation here, not this one, right? So, and then you run off to your nearest whole number. Right. Okay, wait. Right. So let's move on to the next question. So if theta is 76 degrees, determine the equation of the line through A parallel to BC. Through A or parallel to BC. Okay, so then this means that a line that will be parallel, that goes through A, that is parallel to BC, is a line like this, something like this, where it is parallel to OBC. Yeah. So this, if this is 76, yeah, this is 76. Also, by the grade 9, it was in a lot of, so we have what is called fun maths. These two angles are equal. So the interior angles, these angles, they will be equal as well. So this will be 76 degrees as well, right? So a reason your corner is interior angles, right? Okay, let me just rub this off. So we know that for a fact. But now we know that parallel lines on the Cartesian planes, they have what in common? They have what is called a same gradient. So let me just redraw this line. So a line that is parallel to BC, now we know for a fact that these two lines, they will have the equal gradient, right? But we do not know the gradient of OBC. Okay, let's take a breath and try to see if can we calculate the gradient of OBC. If we then calculate the gradient of BC, then we can determine the equation of this line here, right? So this is 76. Hello, CRL twin. You may say your name and say which school do you go to and what grade are you in. Yeah, thank you for joining us. So so where was I? Okay, yeah. So this is 76 degrees, and also we have calculated our theta, which is tan negative 5/3. Right. So now we can also calculate this this angle here. Can we? Yes, we can. Because why? If you consider a triangle BEC, where OEC lies on the x-axis, we can calculate a point. Let's call it O omega. Let's call this angle here O omega. We can calculate this. Yeah? Then how do we do that? We know that. Let's look at triangle BEC. Yeah? We have theta as 76 degrees, and we have alpha as 5/3, but we do not have our omega. But we know that sum of interior angles of a triangle, they equate to 180 degrees. Is equals to 5 plus, right? So this is 76 plus tan negative 1 5/3 plus omega. So this then means that omega equals to what? Let's check calculator. Tan negative 1/5 rather than this tan of 5/3. So it's 59 degrees, close to 60 degrees. So it's 59. So this means that omega is equals to 180 degrees minus 59 plus 76, which gives you 180 minus 59 minus 76. It gives you about 45 degrees. So this means that this equals to 45 degrees, right? So this is 59 degrees. Be careful, we have just rounded off to the nearest unit, right? Okay, let's rub things off. Malo gusto. Good evening, sir. We hope we're going to enjoy this today's session. You may say your actual name and what grade are you in and the school you attend. That will do. So we have calculated the angle of omega, and we have found that it is equals to 45 degrees. So now we have enough information for us to actually calculate the gradient of OBC. Gradient of BC, and it is said to be equal to a gradient of a line that is parallel to BC that passes through A, meaning this line here. So the gradient of these two lines are equal, right? Let's proceed and calculate the gradient of BC. Gradient of BC, we know that it's tan of omega, tan of 45 degrees is what? Probably half or something. Tan 45 or 1, yeah, it's actually equals to 1. So this graph, this line rather, its gradient is equals to 1. So therefore that means the gradient of this line is also equals to 1. Right. But now the question is, let's determine the equation of a line through A to parallel. Through A parallel to BC. Okay, let's give this line a name. Let's call it A what? A what? AM, for lack of a better alphabet. So line AM, we know that its gradient is what? Is 1. And we know equation of a straight line that y is equals to mx plus c. And we know that it's 1x plus c. But now we know that this line passes through A. Now, the only now variable that we do not know is OC. So we can calculate OC using coordinates of A. So we're going to substitute coordinates of A into our equation, right, into our equation so that we can solve for C. Let's proceed and do that. So sub A, excuse me. So it's minus 3 equals to 1, x is what? Minus 5 plus c. So minus 3, take minus 5 to the other side, turns it to plus 5. C, which is minus 3 plus 5, is equals to 2. So now we have solved for C, we have solved for A, and I think we have all our necessary information for us to write down the final equation. So it's in the final equation. Let's just rub all of this off. Alright. So now we know that for a fact that the equation is that 1x plus 2. Right. So this is the equation, or rather the answer of 4.4. So let's go through 4.4 once again on how we did that. First, we determined the value of alpha, and we found out that alpha is equals to 59 degrees. And we were given that theta is 76 degrees, and thus we were able to calculate the angle of omega using a triangle BEC, this triangle BEC. So 76 plus alpha plus omega equals to 180 degrees y. Angles of an interior angles of a triangle, right? And then we solve for omega, and then after we have solved for omega, then we were able to determine the gradient of OBC. So then, since OBC is parallel to a line that passes through A, therefore we know that parallel lines on a Cartesian plane, they have equal gradients. very important. I'll repeat it once more. Parallel lines on an Cartesian plane, they have same gradient. Therefore, gradient of this line is what? Is 1 as well. And then we proceeded to use, since it is said that this line passes through A, we then took point A, then we substituted it to our equation of a straight line, which is y is equal to mx plus c. And then we were able to solve for c, and then we solved for c, then it turns out c that it is equals to what? To 2. So therefore, our equation of a line that is parallel to BC passing through A is what? Is y is equals to 1x plus 2. Right. Right. So, yeah, that is everything clear to, is everything clear? Are there any questions? Please shoot your questions. I would love to answer them. Just rub this.
Seven or seven.
Masenzo quarter past 7. Right, it seems like everyone understands since there are no questions. So, if you have questions or you're still thinking about question, you can write them down after you have thought about your question. We'll gladly get back to you. But I think we can take just a bit of like a 5-minute break. And then after that, we are going to tackle question 5. So this is question 5. You may just browse through question 5 and try to answer it on your own. And then we are going to answer your question 5. And okay, we're not going to finish question 5, but I'm going to do 5.3 and 5.2. Yeah, gonna do 5.2 and 5.3. 5.1 you may do it on your own, but for 5.2 and 5.3 we're gonna do it as a class. So yeah, we are taking a break, like 5 minutes. welcome back, guys. So we going to do question 5, 5.2, 5.3, and that will be it for today's session. So let's go through question 5. So kuthiwa prove without using a calculator that this is equals to square root square root 2 negative or square root 2 over 3, right? So let's go on and prove that it is the case indeed. So let's go to Excali draw. So we have sine 315 degrees multiplied by what? By tan to 10 sine 190 tan to 10. Over cos 100 sine 120. So how do we solve this using, or rather without calculator, just using our brain power? So for such equations, you have trigonometric reductions that you may use to actually simplify these equations, right? Let me show you what I mean by that. So this is equals to, so we know that 315 is equals to 360 minus what? 45 degrees, right? So this means that sine 315 is equal to sine over 360 minus 45 degrees. Upper we know that 210 is equals to 180 plus 30 degrees. No? Plus 30 degrees. And we know that to sine 190 is sine 180 plus 10 degrees over cos, we know that to cos 100 it's either 100 equals to 180 minus 80 or is what is 90 plus 10. Remember, rather note that I'm using 90, 180, 360 as my standard angles. For example, here I used 360. I could have used 270, yeah? But I used 360. We'll see in a second why I used 360. So for this case, I'm going to use 90 instead of 108. So this is 90 plus 10. Right, 90 plus 10 multiplied by, here I'm going to use 180 minus 60 degrees. So it's in a trig reduction. So we have the following trig reduction that we're gonna use. That sine over 360 degrees minus theta is equals to what? Is equals to, is it negative or positive? I think it's positive. No? So this is sine theta. Okay, let's just verify real quick. So if we are taking this point and the minus 360, it's sine theta. So this means that sine 360 minus 45 is simplifies to sine 45. What about to tan? For tan, we have this following trig reduction, that 180 plus theta equals to what? Tan theta. Remember the period of sine and tan. Period of sine is 360 and period of tan is 180 degrees. So multiplied by tan 30 degrees, and we know another trig reduction, that sine 180 plus theta is equal to minus sine theta, right? So this then equates to minus sine 10 degrees over cos 90 plus theta. When we reduce cos 90 degrees plus theta, let me quickly verify it. So this is 90, so this simplifies to minus sine theta as well. You see, when you understand the graphical interpretation of a trigonometric function Z2, you can easily deduce the reductions by simply moving your x, by simply shifting your x-axis, your y-axis, according to your standard angles, whether 90, 360, 180 degrees. So here we know cos 100 minus sine, cos 90 plus theta is equals to minus sine theta. Well, this is minus sine theta, so theta in this case with 10 degrees. So we know that another reduction we know is of a sine, that sine 180 minus theta. Let's verify it real quick. This is our sine graph. So this is 180, and if we move this to here, also it resembles um, a negative sine graph. So this is minus sine 60. So we then simplify. So this cancel this. We left with to sine 45 tan 30 degrees over minus sine 60 degrees. So we have this simplified form, right? How do we then proceed and further simplify this without the use of a calculator? So without the use of a calculator, we also have the following way to do it. Ne? You simply do the following. Ne? For sine 45, to actually know what sine 45 is equals to, you have the following. Ne? You draw a right angle triangle. Ne? So, and make this 45. So this nalapa will be 45. So these two angles are equal, right? So if these two angles are equal, also these two sides are equal. So let's just say it's 1, 1. So using Pythagoras theorem, this is square root 2. So for 30 degrees and 60 degrees, you do the following. So now we know that sine 45 is what? Opposite of a hypotenuse equals to 1 over square root 2, which is equal to square root 2 over 2. Ne? So sine 45 is square root 2 over 2. So now you want to calculate to tan 30 degrees. Oh, let's say this is 60 degrees. This will be 30 degrees, right? And let's say here up at 30 degrees, this is 1. Also, guys, you must know a Pythagorean triplets. For example, what I mean is that one of the triplets that are known is 3, 4, 5. Why? Because 3 squared plus 4 squared is equals to 5 squared. Another one, another triplet is 5, 12, 13. Because why? 5 squared plus 12 squared is equals to what? 13 squared. So these zonge, all those triplets that respect this form are called the Pythagorean triplets. So you must know those triplets. There are infinite number of them. Alright, so here the simplest triplet is that this is 2, this is square root 3. Is it square root 3? No? Yeah, this is square root 3. Why? Because 1 squared plus square root 3 squared is equals to 2 squared. 1 squared is what? 1 plus square root 3 to the power of 2 is 3. So 1 plus 3 is 4. 2 squared is what? 4. So 4 plus 4 is equals to 4. So we have this. So tan 30 degrees, so we know that tan is opposite over adjacent. So tan 30 degrees is equals to what? 1 over square root 3. 1 over square root 3, right? Over minus sine 60 degrees. So sine 60 degrees, we know that sine is opposite of a hypotenuse. Sine 60 is what? Square root 3 over 2. Ne? Square root 3 over 2. Right. Ne? This then simplifies to okay. Two square root 3 multiplied by square root 3 over no. Wait, okay. Let me just let me just write this up at Kaleni. So this 2 sine 45 is square root 2 over 2 multiplied by 1 over square root 3 divided by negative square root 3 over 2. Ne? This equals to multiplied by 2 square root 2, so this cancel this, and then we have the following as, so this is not our answer. So what did we do wrong? Something we did do wrong, guys, and you'll wait, yeah, this is the correct one. Yeah, I thought I was wrong. So yeah, our answer is no, this is not 6, definitely. Wait, over 3 times square root 3 times square root 3 is what? Positive 3, but then we have this negative sign that we forgot. So yeah, this is our answer, guys. Easy peasy lemon squeezy. Was it hard, guys, to solve this? Tell me it was not, guys. Please tell me it was not. So in order for you to be able to answer such questions, you need to know your trigonometric reductions. You do not have to cram your reductions by sine 180 degrees minus theta is equals to negative sine theta. You do not necessarily have to cram it, though you can cram it, but I couldn't need. There's no need. You can do this. And how I do it? How do I do it? You first draw your graph, right? Just a simple graph. If just draw a depending on the trig function that you're trying to reduce, you will draw. If it's a cos, if it's a sine, you will draw a sine. If it's a cos, it's a cos. If it's a sine, it's a sine. So let's say we want to reduce a sine. Though I covered this yesterday, I'll just cover it for today, right? So sine 180 plus theta, like when you have reduced it, like reduce it to what? One way to do this, you can solve this using compound angles, laws of compound angles, and take 180 work as alpha and theta work as theta. Then you solve this algebraically. Or you can do the easier way. The hard way is lay of using algebra, and the easier way is the one I'm going to show you. Yeah. So let's say we want to reduce sine 180 plus theta. How do we do it? Yeah? So this point here is 0 degrees. Yeah? So this is y-axis weight. Yeah? Axis. So what you do, né? So this is 180, né? So you sort of shift your x-axis to 108. 180 is here. Né? You don't really shift your x-axis, your y-axis. Your y-axis doesn't shift, it just stay in one place. But in your mind, you imagine as if your y-axis has shifted to 180 degrees to here. To here. Now this is your new y-axis. New. Ne? And now you inspect the graph. Ne? Now when you inspect the graph, ne, it doesn't resemble a sine graph, because a sine graph iyenyuka, ne? From here it increases. But when you start here it decreases. Ne? But now look careful. Ne? Let me just draw the graph here. This is the graph. Yeah. This is minus sine theta. Yeah. And this is sine theta. You see that this graph, like when you invert this graph, like you rotate it, it'll result to this graph, and when you also rotate this graph, it will resemble this graph. Yeah. So that is why sine 180 plus theta minus sine theta. Right. I will do a reduction ga sine 90 minus theta. Yeah. And I'll show you that it is indeed a reduction in corner. A reduction in corner with cos theta. Right, let me just grab this off. Ne? Ne? Okay. Now let's shift. So this is 90. Ne? So now let's shift your y-axis here to here to in the 90. Now this new graph is something like this. Ne? But now you see this graph is of cos theta. Hence sine 90 minus theta is equals to cos theta. Is because of this. So if you are able to understand what I'm saying, then you will definitely have no problems in knowing how to reduce your trigonometric functions. You just shift your y-axis and then look at your resulting graph, whether, like, which graph does it resemble? Is it cos? Is it minus cos? Is it what? But you will see that, well, it's cos if it's cos, or it's sin if it's sin. But this is the easier way than expanding this sine 180 plus theta and solving it algebraically. You just work with the shifts. You just work what we call phases. We have covered the phases phases at the start of this lecture, right? So, excuse me, guys. So, yeah, this is the final answer we have done, and exactly, Choma. You can definitely use this approach to reduce your trig functions, even in calculus, especially in calculus. Choma.
That's back.
Yeah. Welcome back, as Choma, by the way. Welcome back.
But ufika kasihamba.
Yeah. So yeah, we have proved 5.2. So you can see that 5.2 is worth 6 marks. So by knowing your trigonometric reductions, you can get your 6 marks easily. It's very easily. However, Joma, unfortunately for you, you just arrived just when we were about to stop our session for the day. So that was our last question for the day. Due to time, we were planning to stop at 7:30, and it's approaching 7:30. It's 7:20 now. So tomorrow we are going to start by doing 5.3. You're gonna see when you get to understand trigonometry. It's really not a difficult topic. It's a giveaway topic. It's 3 marks. For example, knowing how to reduce these to this, it's worth 6 marks out of 150, and that's probably like at least a percentage. You understand? Yeah. So yeah, I suggest you do that. It's my pleasure, and thank you to you too for attending. I hope I'll see you tomorrow for tomorrow's session. So yeah, for tomorrow's session, we're gonna cover 5.3, and yeah, we're gonna cover the remaining question 5, and we're gonna do question 6 if we have time, and probably 7 too, because it includes cos theta, so it includes trigonometry. So yeah. So that is it for today's session, and yeah, so that was the plan for this week, to cover trigonometry, and probably next week we're going to do circle geometry or something. I'm not sure, but we'll confirm on Thursday, our last day of the week. So that is it for today. Have a good evening, good night, bye.